Hi guys, welcome to another LivinginSAtv video. David here. Today we will have an amazing video podcast with the CEO of SANSA, the South African National Space Agency. And have you seen these 3 videos about research and the space industry in South Africa? This video will be the holy grail. And remember, as usual, this video will blow your mind. Hi everyone, welcome to another video podcast here in Living in SA. Today we have an amazing guest in our show, which is Dr. Val Musami, the CEO of SANSA, which is the South Africa National Space Agency, and it's such an honor to have you, Dr. Musami, in our show. Thank you very much for having some availability to be here with us. How are you?
Thank you. I'm okay. Thanks, David, and thanks for having me on.
It's only a pleasure. I just want to make a brief introduction to Dr. Val Musami, so you guys can know a little bit better the background of this amazing minds in the space, on the South African space industry. Dr. Musami is the CEO of SANSA and has been leading the South African National Space Agency for the last 5 years. Dr. Musami has a vast experience in the space industry nationally and internationally, having a PhD in physics from the University of KwaZulu-Natal and the Masters in Business Leadership from the University of South Africa, being connected also with several space communities and institutions worldwide. Besides a savvy businessman with a wide experience in governmental institutions like the Department of Science and Technology, Dr. Musami is also invited to several international public speaking events regarding the space industry, such as the most recently African Tech Week and also the Space Operations 2021. That only happened 5 days ago. Dr. Musami continues giving his contribute and positive influence on the benefits of space investment to the citizens of South Africa and beyond. So that was the introduction. And like I say, let's go to the questions because we have a lot to learn today with such an expertise in his field as Dr. Val Musami. Okay.
Thanks.
It's only a pleasure. Dr. Musami, first question that I would like to ask is, why do we need a space program?
So first of all, we have to understand what space means for our everyday life. Okay, so we might not be aware that we use space technology on a daily basis. So for example, if you are watching live TV, I mean, yesterday I watched the Formula One, and that was beamed live. And the way you do that is you're using a telecommunications satellite, which is about 36,000 kilometers away. So from the event itself, they capture the video and they broadcast it to the telecommunications satellite, which is then rebroadcasted to our homes. And that's how we get direct home TV, digital TV. So if you look at all your TV dishes, your DSTV dishes in South Africa, you'll see that they all point in the same direction, meaning that they're all looking at the same satellite. So communications TV comes from a satellite platform. Your weather reports, you know, when you see your weather reports on TV, that comes from a meteorological satellite. When you go to your the malls and you do a banking transaction, all of those transactions go through a telecommunications satellite, and even the timestamp on those receipts that you get comes from navigation satellites. Okay, and then when you're driving and you're trying to look for a location in terms of your destination, and you're using say Google Maps or TomTom, those applications are using navigation satellites. So essentially what's happening is let's say your phone that you've got Google Maps on, it's receiving signals, timing signals from 3 or more satellites, okay, which are spatially distributed in space. So using simple mathematics, you can triangulate where exactly you are on the surface of the Earth, using the timing signals when the satellite actually transmitted the signal, and how long it took to actually receive the signal on your phone. And that triangulates exactly where you are on the surface of the Earth. So navigation requires satellites. And then if you think about farming, so we can, when we put a satellite in orbit, we put these payloads on the satellite. And so, for example, what's useful about these satellites, they're collecting photons, essentially. These are light particles that are reflected off the surface of the Earth, which then gets into the payload. And the interesting thing about these payloads is, you and I can see the world in what we call the visible part of the spectrum. So if you look at the electromagnetic spectrum, there is very short wavelength waves. So for example, if you look at when you go to a doctor's office and you take an X-ray, these are very powerful or energetic wavelengths. So that goes right through the skin and it images your bone structure. So it's very high energy, short wavelength, very high energy. And then you go on the long wavelength side, when you're listening to your radio waves, so those are very long electromagnetic waves that go through the landscape, okay? And so between the short and the long wavelengths, you and I cannot see it. The only thing we can see is in the visible part of the spectrum. So there's other parts of the spectrum that you and I cannot see, for example, in the infrared part of the spectrum. And that gives information about the state of the environment. Like, for example, if from space, you can see or determine which plant you're actually looking at based on the cell structure. So each plant has a different characteristic so that when the light is reflected off it, it behaves differently. And so using that information, you can see whether this is a wheat plant, maize, or just ordinary grass. So you can classify. The second thing that comes from that information in terms of how this light is actually reflected, it's also a function of how much water is in the plant, which you and I cannot see, okay? So if there's a change in the cellular structure or in the water levels in the plant, you can pick that up from space. So we use this kind of information for what is called precision farming. So we can say to a farmer, you need to fertilize because there's a disease encroaching, or you need to add more water because we think your plant is, or we can see your plant is stressed because there's less water, okay? So that obviously has an implication for food security in terms of what we eat on a daily basis. The other application, so when these satellites come through every day, they are in what is called a sun synchronous orbit. They come through at the same time every day. So if the satellite comes at 9 o'clock today, tomorrow it will be back at 9 o'clock, and so on. And what's useful about that is that, let's say you're looking at a water body, and the satellite is picking some sort of spectral signature from the water body. But if at any particular day you realize that the spectral signature is changing or changed, you'll know that there's a difference. There's something is happening in the water body. And if you go look and see, you might see there's diseases encroaching, like cholera, for example. But you see it before you actually observe it in the satellite before you actually see it visibly in the water itself, in terms of the effects. And so with that kind of methodology, you can look at what is called change detection. So you compare day to day, and then you can see if there's anything changed in the environment. And all of this can be done from a satellite platform. So our modern day lifestyle is actually dependent on satellites. So watching your live TV, doing your banking transactions, using your GPS, even flying on an aircraft is made possible through space technology. So we rely on space technology, and so it's very important that from a national point of view, a national country point of view, that we have these kind of technologies that are accessible by our people. And that's the main reason why we need a space program.
Oh, that's amazing. Thank you very much for letting us or enlighten us on the first question. That's really amazing to understand, and I hope that the people that are actually hearing us can understand better why a space program is so important and why countries are actually investing heavily in this matter. So by understanding this now, we know why we need a space program and also the benefits that the citizens of South Africa can have with the space program. My next question, Dr. Musami, will be, this 4.5 billion budget that will be awarded to SANSA in the next 3 years, what will SANSA use this 4.5 billion budget for?
Thanks, David. So if you're looking at the space value chain, there's a whole suite of infrastructure that goes into the value chain. Okay. So first of all, you have to understand what is the user requirement? What is the users actually looking for from a data perspective? Okay. And what our engineers do is they take that information and they package it into what is called user requirements. And then they define the specifications for the satellite. Okay. So what will happen from this budget is we identify the user requirements and then we have specific missions. So we might be looking at about 6 satellites that South Africa will be building using this funding. And then you have to operate the satellite once it's in orbit. So you have to talk to the satellite, make sure everything is working optimally on the satellite, but you also have to bring the data back down. So on a daily basis, as the satellite comes past, you've got to pull down the data. You've got to download the data. And so on a daily basis inside of the space agency, we download about 12, right up to 18 parcels a day, satellites that go past. So that information is pulled from the satellite that is imaging on the Earth. So we have to operate the satellite. So we have what is called a mission control system that talks to the satellite, brings the data down. Now, when you bring the data back down, you have to put it into what is called a data segment. So you might have high performance computing platforms or even a cloud platform. So for example, when we look at Earth observation data, we have data that goes back to the 1970s. These are satellite imageries. When you're looking at data in terms of the magnetic field of the Earth, in terms of measurements that have been taken here on the ground, that data goes back to the late 1800s. So the data is quite extensive in terms of volume, and we have to store it somewhere, okay? And that's essentially the data segment. And then what we're doing, as I said, we're storing it maybe on a cloud platform or a high-performance computing platform. And then we get the experts to build products and services. So they take the data, they repackage it, and they try to build or extract information out of the data, which the end users can then use. So that's essentially what we'll be looking at is a suite of satellites, maybe a new ground segment that will talk to the satellites in terms of antennas. And then when the data is brought back down, we have a data segment. So you'll have a visualization wall where you're able to visualize what's happening around the country. And then you have products and services that will be used by the end users. So we'll be strengthening that value chain with this money that's coming through, the investment that we look at.
Wow, it's so unlimited what we can do with space technology, and I hope in the next few years the investment can actually start being way more, so we can actually start making it even bigger. Okay, so the next question is, what is your vision for SANSA and the future of the space industry in South Africa?
Right. So we've just now adopted a new 5-year strategy for the agency, which started last year. And the focus and the vision of SANSA is to actually, because we're unique on the continent in terms of capabilities and programs, we want to see how we bring that to the African continent. Because in terms of what I've just described with regards to benefits, this is of benefit to the entire African continent. And Africa has already worked in terms of developing its own strategy, policies, and even looking at setting up its own space agency called the African Space Agency. And a lot of that work was done by colleagues here in SANSA in terms of the strategy, the policy, and some of the governance work. So we want to take what's uniquely in terms of capabilities in South Africa and see how we bring that to the African continent so that we can benefit the entire African continent, not just South Africa. And so that's the vision for SANSA, is not just a South African focus, but a continental focus. And then when you look at the future of the space industry in South Africa, so when I talked about the space infrastructure hub and building that infrastructure, what we're going to be doing is all of that is not going to be implemented by SANSA or the space agency. We are then working to bring the industry and contract the industry to help to build the infrastructure. So when you're looking, for example, building satellite, we're going to be contracting the industry to actually build the satellites. It's not going to be built by SANSA. So the industry is going to be contracted and they subcontract each other. So you're building an ecosystem. That's built on the upstream. And then on the downstream, when we get the data in that cloud platform, we're then going to ask the industry to come into the cloud platform and build the algorithms in terms of the products and services. And what's good is that the industry doesn't have to invest in the cloud system. So that SANSA has already done that. All they come in, build this, the software for the products and services. So you'll see the industry playing upstream and downstream. So even the facilities in the upstream will be owned by SANSA. So the industry just comes in, uses the facilities. And so we're trying to get the industry development going by using the investment we have so that the industry can become self-sustainable and grow in the long run. So that's essentially how we see the industry coming on board and being strengthened from the agency perspective.
Incredible, incredible. That reminds me a little bit of what happened to that satellite, the Pathfinder. That was exactly. It was memorable what happened there. What a simple satellite made a whole space industry. Like you said, it created a whole ecosystem. The opportunity to actually create something more. It was incredible. Like I did a 25-minute video. If you guys didn't see it yet, check the link on the description below about all this, because it's mind-blowing what has been happening. And I can say for sure that Dr. Musami will take the space industry even forward in South Africa, and I'm so looking forward to see what the next few years will bring. It's exciting, really. Okay, our next question. We have a very well-developed space industry in South Africa. How you will describe it? What I mean with this is it regulated? Is it how you will compare it to a space industry such America, for example? How advanced is it? How you will describe it in this case?
Yeah, so thanks for that. The upstream, where we're building satellites, designing, and developing. So just to put it from an African perspective, right? We are the only African country that can design and manufacture a satellite within the country. Every other African country that owns a satellite will actually go out and buy a satellite from a manufacturer from abroad, whether it be in Europe or China and so on. So we can essentially boast that we have that capabilities here. And that's because of our industry, because they have the technical know-how. It's a long history of about 4 or 5 decades now they've been involved in this. The same applies with the downstream. We've got quite a few number of companies on the downstream, but I think we can do better in terms of increasing the number of companies that comes through. And even in the upstream, we think given the growth potential that we're going to be realizing in the next few years, there's a potential for a few more companies or many more companies coming into the ecosystem, actually play along this infrastructure value chain that I've been talking about. So the industry is slowly maturing, but I think with all these investments coming in, there's going to be scope for research and development for new technologies, new satellites, new products and services. So obviously we want to work with the industry to develop the industry. And so we'll create what we call incubators or space industry clusters where we support the development of the industry. And that's what we are aiming to do from a South African perspective. So we have in-house capability, but we want to strengthen that. And then just in terms of regulations, you might or might not be aware that space technology is a highly regulated environment, because a lot of the technologies that goes into your satellites and your launch vehicles can be used for dual-use technologies, meaning weapons of mass destruction as well. So for example, the technology, a launch vehicle can be used as a delivery system for nuclear weapons, or it can be used to deliver satellites into orbit. So a lot of the technology is regulated. So we do have regulators here in South Africa just to make sure that this technology does not fall in the wrong hands and it's used responsibly, okay? So we have import-export regimes as well in terms of how we regulate these technologies. So it is a highly regulated environment. And then thirdly, I just want to mention that there is the United Nations Committee on the Peaceful Uses of Outer Space. And so they have what is called treaties and conventions, which most of the countries abide by. It's non-binding, but countries try to abide by it just to ensure that we behave responsibly globally. So one of the key issues we're dealing with now is space debris. With the number of satellites that are out there, happen, and we're going to see a few thousands of satellites. I'm talking about tens of thousands of satellites coming through in the next few years. So the potential for collision in space is going to be increased. So we want to also regulate that in terms of what do we do when there's a potential collision that is bound to happen. So yeah, so it's highly regulated. Our industry is mature enough, I think, to even play globally in terms of the value chain, because some of our industry players have built satellites even for foreign countries, not just South Africa. So there is that capability that we are now trying to build upon. It's also a very regulated industry for the reasons I've just indicated.
I think this is a very interesting one, which is what type of services, space services, can we sell to other African countries?
So the biggest use case for satellite products and services is looking at the environment. So managing your environment, essentially. And that talks to the sustainability issues in terms of how we manage our resources and so on. And, you know, in terms of the benefits I've been speaking from a South African perspective, we also can essentially use that in the rest of Africa. So just give you a few examples of where this can be very critical. So South Africa is, for example, looking at maritime domain awareness. So you want to know how many ships are in your coastline. So South Africa, for example, has a coastline of 3,200 kilometers, if you follow the coastline, and your economic zone going out into the oceans is about 200 nautical miles. And in fact, that area that is owned by South Africa, that coastline, is even more than the land mass itself, okay? So the only way you can monitor that coastline, that economic zone, is through satellites. There's no way you can do it by ships, because that's how the vastness of the oceans, you just cannot cover it. So what we have is we've sent out a satellite in 2018, December. It's a pilot satellite. And that was essentially collecting the signals from the ship. So we can, on a single pass, see which ships are on our coastline. And what we've done is we've superimposed satellite imagery on the signals that we've been receiving, right? So here's the trick. You can see a ship, but you can't see its signal. So that means it switched its signal off. And what we have done is we've sent out the Coast Guard to go and explore and investigate. And in many instances, we've caught illegal fishermen or fishing vessels on the coastline. We've also tracked vessels that were flying low in terms of trying not to be detected. We've actually followed one ship from South America to Port Elizabeth that had drugs on board.
Wow.
So it's using space technology now to monitor and control your coastline. Now you take that into the rest of Africa. So you can't do this without satellites. And we know, for example, there's a lot of illegal fishing that's happening on the coastline of Africa. And very often what we see, for example, is countries will come in and offer assistance to certain countries on the coastline, and in exchange for fishing in those waters. And what you will find is what they take out of the oceans is way less than what they actually give those countries in terms of aid. So you're actually pillaging the oceans. So now we can monitor the activities of these countries using satellites. And then water resources is very critical on the African continent because a lot of the countries are water constrained. So we can map out where the water bodies are actually sitting on the entire African continent, okay? And we can actually also calculate what is called floodlines. So for example, we can tell you where all the water bodies are sitting in South Africa. And if we get certain millimeters of rain, we know that certain areas will be flooded because we understand the topography of the landscape, that if you get so much of water coming in, you're going to have flooding in this area. And we've seen those predictions actually being realized in real life as well, in terms of what we predict. And so you can monitor disasters as well. So you can monitor the water bodies, what's available. You can monitor the quality of the water, and you can monitor if there's a disaster looming. Another big application for Africa is obviously defense, peacekeeping, and security measures. There's a lot of friction and civil wars that are happening in Africa. So we can use satellite technology to diffuse some of the tensions. And a lot of the defense forces use satellite imagery to figure out what's going on the ground, to collect data and intelligence and so on. And every country is trying to do that, but you've got to have your own space capability to do that. So we can look at safety, peacekeeping, security missions in the rest of Africa. So there's a whole suite of applications that we can use that will just unlock the benefits of these technologies, these products and services in the rest of Africa.
That is just mind-blowing. Wow. I just love to hear all those practical examples. Wow, that's wow. I must say, Doctor, let's go to the next question because this is so highly interesting to be able to hear this from you. I would love to go to one of those public speeches that you give on those big events in order to listen live, because wow, this is what we are learning here is just amazing. Okay, so the next question will be, so we know that space is the next frontier, the next trillion-dollar industry, if it's to launch satellites or if it's creating life in other planets, transporting humans, creating space stations in order to send humans to have vacation up there. My question is, in your opinion, are the next generation of South African scientists well prepared to deal with all this fast forwarding? Like every day our world is literally having is jumping beyond the technology, everything. Are our youngsters being able to follow up with all this?
Yeah, so that's a very critical question in terms of building capacity in the system. So for example, in SANSA, we have a human capacity development program. So we give bursaries and scholarships to students who are interested in pursuing careers in space science and technology. And they essentially look at studying at a master's or a PhD level in any one of the disciplines that we support. So we try to create that pipeline of young students, engineers, scientists coming through that will take over one day. And then a lot of those students are being absorbed into the system. Now, in terms of being prepared, obviously, we have to invest in research and development inside of South Africa in terms of different programs. And we want to get as much students involved. They can do the master's or the doctoral studies based on some of these research projects so that they develop those skills as well for the future. And then some of the technologies that we're looking at is now looking at the next level of advancement. So for example, I indicated to you that we have satellite imagery that spans back to the 1970s. Now, if you wanted to figure out what happened in a particular location in Pretoria over all those years, if you take all of that satellite imagery and you process it, it could take you maybe 3 to 6 months to process that and make sense of it. So what we are doing now is we are building what is called a data cube. So this is a technology that was piloted in Australia, and we think this is fairly advanced and a new way of doing things. So you take all your satellite imagery and you stack them, and you mix, essentially you stack them, in what is called a data cube. So if we wanted to ask a question as to what happened in this location since the 1970s up until today, that can be done in essentially 2 to 3 hours, as opposed to 3 to 6 months. All because we are reusing the technology, pre-processing it, and putting into a platform where it's easily accessible. Okay. Now that becomes very important, let's say from a government perspective, right? You have a water body, let's say a lake out there, and you want to know, how do I impose certain policy or policies to improve the quality of the water? So first of all, I use the data that I have for what I call evidence-based policy making. So I can look right back to the 1970s and see how the water body changed over time, whether by the volume or the quality, right? And based on that, I can look at seasonal effects. I can look at people interacting with that water body, and I can make decisions or policy choices based on the evidence I've got. And then when I implement the policy, I can then monitor if it's making any difference. Okay, so I use it to inform the policies, but I also use to monitor how the policy is being implemented. And that example was done in Australia. And what they figured out was immediately after making the policy decision and implementing those policies, the water quality, which was fairly bad in the past, suddenly became high quality water, so they could use it. All because they implemented the policy choices based on evidence. Okay, so now you see the power of all of this. And now you can bring in artificial intelligence and big data analytics, because you throw that, because it doesn't make sense for experts like you and I sitting in front of a computer and trying to make sense of this. Now you throw algorithms at it, machine learning codes, which then figures out, look, something is happening in the system, and it raises a flag. So you can automate this entire system, but then you need software developers, engineers, scientists to make sense of this. And this is where the new cohort of young engineers and scientists can come in and work in terms of pushing those boundaries. So it's exciting.
One of my viewers asked me, did SpaceX try to contact SANSA? It was some type of joint venture going on, or some, let's say, there was anything in that matter between SpaceX and SANSA, or not really?
We don't have what is called joint projects, but we have some insights, right? So we've got a ground station here in SANSA. And this ground station, probably in a few months' time, will have about 70 antennas on the ground station. So these antennas are talking to different satellites and so on. But what we also do is what is called launch support. So if you think about it, every time there's a launch from the US and it comes this way, and if there's a launch from the European Space Agency in French Guiana and it comes this way, if you think about it, those countries or regions cannot see those launch vehicles when it's over Africa. They lose sight of it. Okay?
Mm-hmm.
So this is where SANSA comes in and provides support to these launch campaigns. And very often, the satellites that are sitting at the, the satellites are normally at the top of the rocket, what is called the upper stage. So when the rocket gets to the right orbit, the upper stage sort of opens up and the satellite is ejected, right? And very often that happens over our footprint. So we switch on the satellite and we do what is called in-orbit testing of the satellites, and we pass it on to the client. And sometimes you need orbital corrections. That all happens over our footprint. So just to give you a sense, when those launches are happening, there's South African involvement. So even some of the Mars missions, it's actually supported from here in South Africa. And like the Chandrayaan mission with the Indians tried to land on the moon, that was fully supported from SANSA as well in the ground station. Because if you look at, for example, the Mars missions as an example, if you think about it, the US launches the probe, and then it's on its way to Mars, right? But the Earth is rotating. So the US sees it now, and as they rotate out of view, another ground station comes in and talks to the probe, and as it rotates, and so on. So there's a ground station in Australia called the Deep Space Network. There's one in Spain, and there's one in the US. Now we're looking at establishing a fourth deep space network here in South Africa. And that is still open for discussion. And I think we've done the environmental impact assessment. So we're looking at working together with NASA in terms of hosting that. And if we go ahead and establish that ground segment, it'll just support all the lunar and the Mars missions going forward as well. So there's huge opportunities for South Africa going forward in terms of all of these projects that are coming online. So we have the capability, and I certainly think in terms of the advances we're making, we should not rule out that maybe in a decade or two, there will be planetary missions coming from South Africa as well. And that's not something we should rule out at this moment. We want to keep our young students and engineers and scientists excited. So we're slowly building up to that excitement as well.
So, thank you very much. There is so much going on my mind right now about this. You just opened this, let's say, universe of possibilities in my mind, or what we can achieve, and all that. I want for you two that is watching this podcast to be able to understand what Dr. Musami is talking about, because this is fascinating. I must say, wow, it's so fascinating. Okay, let's go to another question. Is how well aware is the South African public about the space industry?
I think we are slowly ramping up the awareness. So you might see there's quite a few projects that we are communicating around. And one of the big initiatives that we're currently working on, I should mention, is called a Space Weather Center. So we have the only internationally accredited Space Weather Center in SANSA for the whole of the African continent. Now, the International Civil Aviation Organization has passed a set of regulations that says that all flights, when a pilot, before they take off, they must have space weather information on board to inform the flight itself. And the reason for that is your flight is affected by what's happening out in space, okay? So if there's a disturbance from the sun, it actually affects how the satellites are operating. So you might have, because the aircrafts are using your global navigation satellite services for navigation, you might get a blackout, so they don't know where they're flying during a disturbance. So you lose your navigation control of the satellite, also the aircraft. The other thing that happens, if you understand how the pilots communicate with the ground segment, they are transmitting a signal. That signal is being transmitted and it's reflected off the ionosphere, which is like charged particles, and it's reflected and bounced back towards the ground, okay? And what actually happens when you have these disturbances, these particles get absorbed, or the radio waves get absorbed, and then the pilot cannot communicate with the ground station. There's what is called a communications blackout. And so you also get excessive radiation, because when you're flying, you get naturally radiated. There's radiation up there, right? But during these active events, you get more radiation than not. So what's actually happening, you get radiation, you don't know where you're flying, and you can't communicate. So that's a hazard for flying. And so the pilots need to know up front what's happening. And we've created now a huge interest from the public in terms of these kinds of projects. It's going to be a 24/7 operations. And in fact, we launched this new initiative on the 9th of March, and they already started the construction of a new building for a new space weather center, which will be state of the art as well. And already you see the public is hugely interested in what is going on, even from internationally. There's interest in the space infrastructure hub. We do outreach. So every year we reach about 25,000 young students through our outreach programs. We have a mobile lab that goes out into the rural schools that don't have laboratory facilities. And this is it's essentially a vehicle that opens up and you have all your experiments in there. So our experts then run those experiments at the school so the students can get a first-hand knowledge as to how these experiments work rather than just reading about them. So we're creating a lot of excitement around public awareness. So I think there's still a lot more that we need to do, but the public is slowly coming up to par as to the value of space in their daily lives.
Wow. Well, that's so nice to hear. That's so inspiring in so many ways. Because, like I said, sometimes it's nice to know what we have indoors in order to value what we have. And having such a well-developed space program, it's so exciting for the future of South Africa and for the African continent itself. Okay, let's go to the next question. And this is my personal question, which is, what is your favorite astrophysicist?
I think Stephen Hawking was one of my favorite astrophysicists. And I should also mention Albert Einstein. You know, if you follow from a physics point of view the work of Sir Isaac Newton, Newton's laws and so on, that's what is called classical physics, right? So you can figure out, okay, this actually makes sense. But when you get into theories of relativity and you understand the kind of thought processes behind some of these theories, it's not straightforward, but it opens up an entire new universe. So like quantum physics, it's not something that ordinary people understand of how things operate at the micro level. There's a whole new universe that's opened up. And so the likes of Albert Einstein and Stephen Hawking that worked in this kind of field, it's phenomenal to actually understand how the universe works. And what both of them have done, if you think about, if you look at the night sky tonight, the closest star is Alpha Centauri, which is 2.4 light years away. And if you understand that light travels at a velocity of 3 × 10⁸ meters per second, what that means is that light that has left that star, which is now reaching your eye, has left that star 2.4 years ago.
Sure.
So you're seeing that star 2.4 years back in time, right? And so when you look further back, that means where the Big Bang started, that's like 13.7 billion years ago. So any light that's coming from that vicinity is actually left that star 13.7 billion years ago.
It's just
And
remarkable.
it's difficult to comprehend and understand how this actually fits together. But if you take the universe and look at the universe at night, you and I only understand about 5% of the universe. Then there's 95% of the universe that we don't understand. And both Albert Einstein and Stephen Hawking, they kind of worked on theories around which kind of influence and make us understand how the universe comes together. I mean, we talk about dark energy, dark matter, and people think, okay, what is this? I mean, how do you, I mean, think about it. When you look at the galaxies, right? So you have these galaxies, which are compact regions where you have like 100 million stars, like our Milky Way galaxy, where the Earth is part of that. We're part of this, our own solar system, where you have the sun and the planets rotating. But our sun is just one star in the Milky Way. There's hundreds of millions of stars, right? So that's one galaxy. So what's keeping the galaxy together? Why does, so if you look at the universe on the whole universe is expanding, right? But what's keeping the galaxies together? They're not expanding, but the universe is expanding.
It's a very good question.
Right? So in terms of what's keeping it together, like Sir Albert Einstein's theories, you must have matter. So gravity pulls together things to, you know, and keeps it together. So you must have matter. So there is something there that we can't see. It's called dark matter. So if the universe is expanding, why is it expanding? So there's something there that's pushing it. You need energy. So there's dark energy. And, you know, when you start to understand and interpret what's happening in the universe, these are the pioneers that kind of put the theories in place that helps us to understand some of these things. But as I said, there's 95% of the universe we don't understand.
Doctor, I promise you, I would love to have conversations with you for entire hours. Go and check Drake equations, the Kardashev scale. I'm mad about this stuff. I promise you. I'm just thinking that in the center of every galaxy can be a black hole that can suck literally every existence. That knowing that, like you said, the light can come from a star that's probably already dead, and we saw the light of the explosion of 2.4 billion trillion years ago that happened. So, are we having a vision from the actual present or the past? So,
yeah,
the universe bends the human comprehension in such a radical way.
absolutely.
It's just remarkable.
By the way, I should mention there is one project which is also going to revolutionize our understanding of the universe. It's called the Square Kilometre Array, and it's being built right here in South Africa. So just to explain that, the radio, you know, there's radio waves coming from the universe. So we have these radio telescopes that are imaging the radio waves. So stars are also emitting radio waves, right? So we can see what's out there by just collecting the radio waves. But the radio waves are very faint. So, you know, the signal is very faint. So what you want to do is to have a bigger telescope as possible that will collect as much radio waves. The bigger the antenna, the better your ability to capture even a faint signal. So what we're trying to do is to build an antenna that the surface area is 1 square kilometer.
SKA.
Okay. Which is called the SKA, the Square Kilometre Array. But it's an array because you want this antenna to be geographically distributed. Okay. And that's so that you can get what is called the resolution you require. So for example, let me give you an example. If you want to calculate the distance to a star, right? So you go to one point of the Earth, you look up, you know the angle, you go to another point of the Earth, you look up at the same star, you calculate that angle, and if you know what the baseline is, You can, using a triangular method, you can calculate the distance, your geometry, right? But the error of that distance is based on your baseline. So you want what is called a very large baseline. So this is where the term very long baseline interferometry comes from. It's exactly that. You want your baseline to be as far as possible. And this is why you want your antennas, if you've got, so there's going to be about 3,000 antennas, but you want them to be distributed as far as possible. So these antennas will start from South Africa, they will go up to Ghana, which is about 3,000 kilometers. So you get these very long baselines that can improve the accuracy. And so what this radio telescope does, it allows you to then pencil into the universe to figure out what happened near the Big Bang, essentially. Because now you've got these powerful radio telescopes that have these collection surfaces that can collect even very faint radio waves that's coming from the Big Bang. And the big problem you have, which is what is even more incredible, is that if you take these 3,000 antennas that's starting from South Africa right up to, let's say, Ghana, Mozambique, Mauritius, and so on, all of these telescopes are actually one telescope. They're not 3,000 different telescopes. So you need optical fiber links that links up all the telescope, and they're all correlated, meaning they're acting as one instrument, right? The big problem with that is you have to bring all of the data together, and this is what is called a big data problem. The data that's coming from these antennas is going to be anywhere between 10 and 100 times the global internet traffic in the world. So now you need technologies, some of which don't exist, to be able to operate those kind of telescopes. And a lot of those technologies are being built here in South Africa. So it's helping us to also leapfrog into the fourth industrial revolution using space science projects like radio astronomy, your satellite missions, and so on. I thought I should just throw that out to you.
That was actually my next question, was the SKA. So it was perfect because you literally read my mind. That was literally a cherry on top of the cake. Oh, okay. Doctor, I think this is basically all the questions that I had. If people want to follow what SANSA is doing, SANSA has their own website, their own YouTube channel, which they are quite active. I don't know if you would like to add anything else, Dr. Musami.
Yeah, we've got our Twitter feed as well. And I think, Vinesh, we can tell you there's also a Facebook feed. So you can catch us on LinkedIn and Twitter as well, which is where I normally tweet and send out some of the work that we're doing. Yeah, so we can share that as well.
That's amazing. Thank you very much, Dr. Musami. It was such an interesting conversation. I wish you had more time so we could do this for hours on end, because this is so incredible to be able to speak with someone with your knowledge and your expertise. And like I say, this is just 1.3% of what we could speak, but we just tried to brush a little bit to let people know what is the space industry in South Africa, and was so captivating to have this conversation. I must say, I learned a lot. You made my day. Thank you.
Good. Well, thanks, David. We look forward maybe to another session at some point in time in the future. So let us know.
It's only a pleasure. Thank you very much, Dr. Musami. Thank you very much also, Vanishri. And this was everything. Please let us know down below in the comment section if you guys liked. Make all the questions if you want a part 2 with Dr. Musami. We'll be trying to arrange definitely another session. And thank you very much. My name is David, and see you in the next LivinginSAtv podcast. Wow, wasn't this amazing, guys? Don't forget, like and subscribe. Destroy that like button, share, do all the great stuff to make the channel grow. Thanks for my Patreons. Thanks for everyone that supports the channel. And once again, I will see you in the next LivinginSAtv video podcast.